Conduct a hypothesis test and provide the test statistic, critical value, and p-value, and state the conclusion. A person drilled a hole in a die and filled it with a lead weight, then proceeded to roll it 200 times. Here are the observed frequencies for the outcomes of 1, 2, 3, 4, 5, and 6 respectively. 21, 31, 48, 40, 28, 24. Use a 0.025 significance level to test the claim that the outcomes are not equally likely. Does it appear that the loaded die behaves differently than a fair die? This is an example of a goodness of fit test. We have observations recorded here. 1 was rolled 29 times, 2 was rolled 31 times, 3 was rolled 48 times, and on out. Now, if the dice were fair, out of 200, we would expect 200 divided by 6 for each group. So we're going to go to StatCrunch, and we'll type in those values that we see. So we have 29, 31, 48, 40, 28, and 24. These will be our observed values. So I might even label that column observed. And then we will have an expected column. And what we expect is 33.3. For each of these numbers of spots that turn up on the dice, if the dice is fair, if we expect that each side has an equal probability of turning up each time. So we'll push stat, goodness of fit, chi-square test. Observed, we went ahead and labeled observed. Expected, we labeled expected. Click compute, and we will get a chi-square value of 11.98. So the test statistic is 11.98. The critical value we will get from a chi-square calculator. So we'll click Stat, Calculators, chi-square. The degrees of freedom are 1 less than the number of categories, so 6 minus 1 is 5. And in our alpha value is 0.025. We'll click greater than. We're supposed to round to 3 decimal places, so we'll have 12.833. The p-value is 0.0351. And here we are to state the conclusion. Now this critical value is larger than the test statistic, and the p-value is larger than the level of significance. So we will not reject the null hypothesis. There is not sufficient evidence to support the claim that the outcomes are not equally likely. The outcomes appear to be equally likely, so the loaded die does not appear to behave differently from a fair die.